This video covers topic 12.3 over factoring with the greatest common factor. A greatest common factor is the largest term that divides evenly into a set of terms. Terms can have numbers and or letters. So that's just a brief reminder of what a term is. So terms can have numbers and or letters. So when we find our greatest common factor, we have to work through the prime factorization of all of these numbers. This means we need to make a factor tree. From a factor tree, you start with your number of 8, and you break it up into two numbers that you could multiply with 8. Unless 1 is your only option, because you don't really need ones in a factor tree, you need to try to find things other than 1. So like putting 8 and 1 wouldn't really help me because it's not breaking this down. So with a factor tree, you're working to break things down. So 8 is a combination or a multiplication of 4 and 2. Now 2, we can't break down any further. We could, but we would only have 2 and 1, and that doesn't help me. But 4, we can break up into 2 and 2. So my factors, my prime factors of 8 would be 2 times 2 times 2. So I'm going to write that out. A way you can check yourself is if you put this into the calculator, you should get what you started with. 2 times 2 times 2 is 8. So when we look at 12, you could break 12 up a couple of different ways. You could break it up into 2 and 6. You could also break it up into 4 and 3. You only need to choose one option. But if I say 2 and 6 and you are thinking, oh man, I would have done 4 and 3, you can do 4 and 3. It does not matter as long as the two numbers that you pick multiply back up. They follow up the tree back to your original number. 2 cannot be broken down anymore, but 6 can be comprised of 2 times 3. If you were working over here, you would have 2 and 2. No matter which tree you do, you would have the numbers or the factors 2, 2, and 3. So we're going all the way down to what I call the leaves on the factor tree. So they're the things that stick out on the very end. Remember that 6 doesn't disappear, but you've broken 6 up into 2 and 3. So you've changed the way you represent 6 into 2 and 3. So we wouldn't put 2, 2, 3, 6 because 6 is comprised of 2 and 3. So you break 12 all the way down until you can't stop or you can't go any further. So 2, 2, and 3 are my leaves, the ends of the branches, and there I'm done. To double check, 2 times 2 times 3 is 12. So we have our two prime factorizations for these numbers. The greatest common factor between 8 and 12 is going to be the greatest combination of both of these prime factorizations. Both of these share a 2, and they share another 2. Now, 8 has a 2, and 12 has a 3 that they do not share. So my greatest common factor would be 2 times 2, which is 4. So 4 divides evenly into 8 and 12. So when we look at problem 1, greatest common factor, we need to find our factor trees and see what they have in common. 6 is 2 and 3. 2 cannot be broken down further. 3 cannot be broken down further. The way I find my answers is I rewrite them and line up any numbers that they have in common. So 18, we could do 3 and 6. You could do 2 and 9. 6 can be broken up further into 2 and 3. And something I commonly do, excuse me, is underline my factors when we get to the end so I don't lose any. So 18 is 2 times 3 times 3. So if I line them up this way, I am looking for what they share. They share a 2 and a 3, so they share a 6. 6 is divisible by 6. 18 is divisible by 6. So my GCF, the biggest number that I can take out of both, is a 6. Note, I can't take out anything bigger than what I have. So 6, I can't take out anything bigger than a 6. So if somehow you got a 9, that wouldn't be possible because you can't take a 9 out of 6. Now when dealing with exponents, we know x to the 5th is x this many times. So x times x times x times x times x. And then x cubed is x that many times. Again, if you will line them up this way, we can easily see what they have in common. They have x times x times x, which is x cubed in common. X times itself 3 times in common. So 3, we're dealing with letters and numbers. I'm going to deal with the numbers first. So 16 is 4 times 4. You could also say 2 times 8. It does not matter as long as the two numbers you pick multiply up to 16. 4 can be broken up into 2 and 2 and 2 and 2. My 2's are my end points. So 16 would be 2 times 2 times 2 times 2. 20 we could break up into 2 and 10. You could also break it up into 4 and 5. Again, how you get there does not matter as long as your end results are the same. 2 cannot be broken up further. 10 could be broken up into 2 and 5, but 2 and 5 cannot be broken up further. So I rewrite my factors. 16 is 2 times 2 times 2 times 2. 20 is 2 times 2 times 5. And I can see that they share a 2 times 2. 2 times 2 is 4. Now looking at my letters, I have an m squared, so that's m times m. And I have an m cubed, which is m times m times m. Again, line them up. They have an m times m in common, which is an m squared. So the biggest thing I could divide out evenly would be a 4m squared. So your GCF can be a combination of letters and or numbers. In this case, it's both. Sometimes you just have numbers like on problem 1. Sometimes you just have letters like on problem 2. Sometimes you have both like on problems 3 and 4. So 4, we're going to do the same thing. Break 56 up first. 8 times 7 would give me 56. 8 I can break up into 2 and 4. 7 cannot be broken up further. 2 cannot be broken up further, but 4 is 2 and 2. So 56 would be 2 times 2 times 2 times 7. I'm sorry, yeah. 2 times 2 times 2 times 7. And again, if you're not sure, 2 times 2 times 2 times 7. And we get 56. So if you want to double check, make sure you wrote them all, because sometimes we lose leaves like right up in here at the beginning. So if you're afraid of that, double check what you wrote. 32 is 4 times 8. 4 is 2 times 2, and those 2's cannot be broken up any further. 8 is 2 and 4. 2 cannot be broken up further, but 4 can be broken up into 2 and 2. So on 32, I have 2 times 2 times 2 times 2 times 2. And notice how I lined them up. I lined up all the 2's I had, and then anything that was extra or excess, I wrote out to the side. So 2 times 2 times 2 is what they have in common, which is an 8. Looking at my letters, I have a c squared, so that's c times c. And I have a regular c, which is just c. So they share a c. So their greatest common factor would be 8c. On the back, we're asked to multiply. So when we multiply, you can distribute or you can set up your box. 4x, x plus 5. No matter which way you do it, you'll get the same thing. 4x times x is 4x squared. 4x times 5 is 20x. So 4x squared plus 20x. That's from notes 12.3.2. Factoring is working backwards. So in a sense, it's dividing, but it's more than just dividing. It's basically undoing, okay? So in order to fill in this box, we multiplied. So we undo our multiplication to factor. Today, in order to factor, we're going to find our GCF, our greatest common factor, and then divide it out of all of these terms. So on 4, to find my greatest common, on 5, to find my greatest common factor, I break up my numbers. 4 is 2 and 2. 3 is just 3 and 1. So I have a 2 times 2, and I have a 3 times 1. There's nothing that these guys share in common number-wise, so there's not going to be any numbers here. Then x squared is x times x. X is just x. So they will share one x. I take my GCF and put it out front and start a set of parentheses. And then this is when I divide. So whatever my GCF is going to be divided out. My result, or whatever's left over, is going to go in the parentheses. So I have 4x squared being divided by x. One of those x's cancel, and I'm left with 4x. Negative 3x divided by x. My x's cancel, and I'm left with negative 3. Problem 6. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 and 3. 6 is 2 and 3 and cannot be broken up further. So I have 2, 2, 2, and 3. And then 2 and 3. So these share a 6, or 2 times 3. With my x's, I have an x squared, which is x times x, and then x. So these share a 6x. Whatever they share goes out front, and I start my parentheses and then divide. 24 divided by 6 is 4. X squared divided by x is x. Remember our exponent rules, we subtract, so 2 minus 1 is 1. 6 divided by 6 cancels. X divided by x cancels, so we just put a plus 1 as a placeholder. Because it doesn't disappear, it just cancels, so we leave a placeholder of 1. For 7, 12 is 4 and 3. 3 cannot be broken down, but 4 can be 2 and 2. So we have 2, 2, and 3. 16 is 4 and 4. 4 is 2 and 2, and 2 and 2. So we have 2 and 2 and 2 and 2. So we can see these share a 2 times 2. Looking at my letters, a cubed is a times a times a. A squared is a times a. So these share an a times a. So they share a 4 and an a squared. My GCF, whatever I'm dividing by, goes underneath and then out front. When I divide, 12 divided by 4 is 3. A to the 3 minus 2 is 1. And that's from our exponent rules from the last unit. Negative 16 divided by 4 is a negative 4. A squared divided by a squared cancels. 8 has 3 terms, so I need to find something that is in all 3 terms. So first I start by factoring. 10 is 2 times 5. 20 is 2 times 10. 10 is 2 times 5, so we have 2, 2, and 5. 5 is just 5 and 1. So when I line them all up, they all share a 5, and that is it. Even though 2 of these numbers share a 2, they don't all share a 2, so I can't take a 2 out of all of them. With my letters, y cubed is y 3 times. Y squared is y 2 times. And y is y 1 time. So they all share 1y. So I can take out a 5y, or a 5 and a y, from all 3 terms. Whatever I take out goes in front, and then we divide. 10 divided by 5 is 2. Y cubed, so y to the 3 minus 1 is 2. 20 divided by 5 is 4. Y squared divided by y is y. We subtract. Negative 5 divided by 5 is a negative 1, and my y's cancel. Note that in my parentheses, all of my numbers have gotten smaller and all of my letters have gotten smaller because I'm dividing out a number and a letter from every term. So 2 more problems. Start with your numbers. 16 is 4 times 4. 4 is 2 and 2. So I'll do it here. 8 is 4 times 2. 4 is 2 and 2, and the other 2 can't be broken up further. So 2 times 2 times 2.
Are we back online?
Yeah. And then 4 is 2 times 2. So 2 times 2. So when I line them up, I can see we have a 2 times 2 that they share. And then looking at my letters, x cubed is x times x times x. X squared is x times x. And x is just x. So they share a 4x. Remember that whatever they share, we take out of all terms. And now I divide. 16 divided by 4 is 4. X to the 3 minus 1 is 2. Negative 8 divided by 4 is negative 2. X to the 2 minus 1 is 1. Negative 4 divided by 4 is negative 1. X divided by x cancels. Note that because you are dividing out, you can only divide what you have. You cannot divide more than you have. So if you divide and you get fractions, you've divided too much. Our last problem, 6 is 2 times 3. 4 is 2 times 2. And 2 is just 2, or 2 times 1. So we have a 2 times 3, 2 times 2, and a 2. So they all share a 2. And then x to the 4th is x times itself 4 times. X cubed is x times itself 3 times. And x squared is x times itself 2 times. So they all share x times x, which is x squared. So I'm dividing a 2x squared from all of my terms. Remember that whatever you take out must be divided evenly by all of your terms. 6 divided by 2 is 3. X to the 4 minus 2 is 2. 4 divided by 2 is 2. X to the 3 minus 2 is 1. Negative 2 divided by negative 2 is negative 1. X2 divided by x2 cancels.